I'm here to talk about your day two operations with Kubernetes. I'm Jeevan Joseph. I'm a product manager within the Containers and Kubernetes team. And before we get started, can I get a quick show of hands, how many of you use Kubernetes in production today? Okay. So, before we get into day two, I'd like to quickly go over how people get there, right? So typically we see a lot of customers, a lot of developers starting with an application modernization effort, right? Either you're building something from brand new from ground up, or you're taking an existing application and figuring out how to modernize this, right? So, you could do this one of two ways. You could try to decompose the application, move into a microservice model, or you could kind of start off with your existing application and try to bolt on new features as microservices, right? Now, regardless of what approach you use, what tools you use, the general ideas behind this would be a focus on microservices, a focus on how you manage application state, and how you manage dependencies between these microservices, right? From that planning phase for your application, you kind of move on to creating your first cluster, your first Kubernetes cluster, right? And when you do this in a production quality manner, you're thinking about how do people access this cluster? How do I enable access to this cluster to my developers, right? You're moving beyond running a small cluster on your laptop or a test cluster of some kind where everybody's a super user, right? You're moving on to how do I properly provide access? How do I establish connectivity with other systems, right? Especially if you have a complex system that has connectivity to your on-prem existing systems and other dependencies, how do you establish connectivity? And when you're running on a cloud provider, you are also thinking about automation, right? Because this is one of the big benefits that come with any cloud vendor. You have the ability to automate your infrastructure, right? So you move on from application modernization focus to creating your first cluster where you actually focus on these kinds of things, right? Then you do an application pilot. And what an application pilot is, this is the phase where an infrastructure team typically vends out access to this cluster to an application development team. And in a lot of cases, these infrastructure teams and application development teams are the exact same teams, right? But in some organizations where that separation does exist, it might be another team, right? You deploy your first application. You start experimenting with Kubernetes tools, right? This might be for people who are new to Kubernetes. This might be a bit of a learning curve, right? We heard already today, a few of our other speakers talk about Kubernetes and its complexity, right? So, you need some time to get accustomed to this complexity, and you can use tooling that can alleviate some of this. But this is where you're, getting your bearing, so to speak, right? Then you move your first application into production. You're figuring out how to do deployments effectively, how to do rollbacks effectively. How do you troubleshoot? Because things do go wrong, right? All the time, right? So especially when in production, right? You're figuring out these kinds of. This is your focus area, where you're troubleshooting, where you're trying to figure out deployments and rollbacks, where you create runbooks so that you can do this repeatedly and with a good amount of certainty and predictability. And after that, that's where you really get into, okay, I've made this work for one application. All of this looks good. Now I want to make this widely available across my organization. How do I scale this, right? And that's going to be the focus of our talk today, right? We're going to focus on observability, security, automation, and optimization. So these are the prime focus areas. Once you have your first application done, you want to scale this approach. You want to scale this methodology to all of your application teams, right? And observability is not just, seeing resource consumption. It is actually deriving insights. How can I run my application better? It's not just about knowing what my application is consuming, but it's actually deriving insights from that kind of data. It is about security, where you have to figure out how do I secure my application and all its dependencies? What are the security attack vectors for my application? How do I mitigate this? What are the places where it can go wrong, and how do I fix that? Automation, again, if you want to run at cloud native velocity, then we need automation, because as you will soon see, microservices, there are a lot more moving parts than your monolithic applications, and these moving parts means that there's more work to do. But how to do that effectively, we leverage a whole lot of tooling and a whole lot of automation, right? And once we have all these in place, then it's time to optimize, right? Because again, we can derive insights from our observability tools, we can derive insights from our security tools, and we can automate, which will lead to optimization of like, how do I consume fewer resources? What resources am I wasting? How do I scale down those resources? How do I scale up the resources that I need? So you effectively start optimizing your application. So before we go any further, I just wanted to throw this up here. Typical cloud native application, typical set of microservices. This is actually a real application, by the way. The code's published on GitHub. You can check it out. Just to quickly go over it, this kind of model is a very simple e-commerce, shopping experience of sorts. And again, kind of thinks through this cloud native approach, right? Where you use the best tool for the job, right? So everything inside that Kubernetes box, you would see that, there's a multiple varieties of tools and technologies used, right? This entire e-commerce application is built with a bunch of microservices. You have services that do tracking, you have services that do catalogs, you have services that manage users, you have services that provide cart functionality in the shopping experience, you have an order management service, a payment service, fulfillment service, and so on. And if you notice closely, right, some of these are written in Node.js, some of these are written in Go, some of these are written in TypeScript, and a few of them are in Java using multiple frameworks, Helidon, Micronaut, Spring Boot. So again, the focus is on not kind of trying to standardize on any one thing, but using the best tool for the job, right? So if you think a particular stack is really good for accomplishing a goal, with a microservice architecture, you should be able to do that. And all the services outside, those are the services that this application uses, those are its dependencies, right? So you would see that a few services depend on object storage, which is represented as a bucket here, right? Some of them use the OCI streaming service. Some of them use API gateways. A lot of them use a database, right? And all of this application is protected with a web application firewall, and traffic is distributed to a load balancer, right? So these are the typical types of components you see in any cloud native application. But within the Kubernetes cluster, you would see a multitude of services, a multitude of dependencies from each service to another, right? And this is what makes Kubernetes and cloud native applications achieve that kind of velocity, because think about it. If there is an update to the order management application, I don't have to deploy everything. I can just deploy the order management application, right? I'm not taking a dependency on anything else. That's an independent application standing alone, all by itself. All the other applications are interacting with it through stable APIs. So each team is able to move independently. You're not trying to do this global synchronized locking system, right? Everything can move on its own pace, which gives you or unlocks the potential of being able to move independently and being able to move fast. But as the picture clearly indicates, this looks a lot more complex than a traditional monolithic application, where all of this functionality might be a single application. So this brings to fore the main concern of like why we need to get smart about observability, security, and automation and optimization. So let's start with observability. So here, the main challenges that we just saw, right? Applications are distributed. The infrastructure is dynamic. You're scaling your infrastructure on demand, right? So on a weekday morning, you might have 50 nodes serving up your application to meet actual demand, right? On a weekend night, that might scale down to 10 nodes, or 5, or 0. So again, you have more moving pieces, which means there are more complex dependencies. All of these individual applications, all of these individual interactions is generating data, and that creates a lot of data. And like, data is great, right, when you can understand it, but having too much data where you don't know where to begin or where to end, not so great, right? Metrics are fragmented. The tooling is fragmented. How you observe a Node.js application might not be the same way you observe a Java application. The kind of things to observe are different. And this leads to a lack of cohesion, right? Now, there are a lot of tooling available within the Kubernetes ecosystem that can help address these, right? But I want to focus on that this tooling is not just about resource consumption, right? Because every time I interact with developers, in a lot of cases, right, developers kind of tell me, but yeah, we have these really awesome dashboards, right? Observability is not just about dashboards though, right? Because dashboards are awesome for the first 3 days that you create it, because after that, nobody's actually looking at them, right? So a dashboard that nobody looks at is pretty useless. So in the exact same manner, if we want to derive insights from this, right, we need to not just have these great dashboards, we need to understand and correlate and have a cohesive insight being generated from the data that is being collected, right? It also needs to integrate with your existing infrastructure, existing tooling and your existing workflows, right? For instance, we need to have alerting, right? It is a basic requirement, right? Having dashboards are great, but getting to know that something is off at 2 in the morning is even better, right? That's when you want to come and look at the dashboard, trying to figure out what's going on, right? Again, we talked about, let me go back to the last slide really quick, right? So here, the most obvious and the most ubiquitous tool for this type of observability within the Kubernetes ecosystem is Grafana, which is usually backed by Prometheus, right? And Grafana and Prometheus combined together will give you a lot of these capabilities. However, the cloud native ecosystem is very broad, and it offers you a lot of tools to even go beyond that, right? Like, for instance, understanding the relationship between your microservices, right? In our earlier slide that we saw a lot of services talking to each other. How do you understand who's calling who, at what rate? Where is the bottleneck? Are these services responding at the right level of latencies or having the right level of response times? What is the latency in the network? So Kiali is a tool that can help you understand this. It's part of the Istio service mesh. And tools like these, again, we're not, the advantage of using Kubernetes in the first place is that you get access to this vibrant ecosystem of tooling that helps you drive these types of insights, right? Pixie is another tool, right? And Pixie is based on eBPF, which is a really, really efficient way to monitor your systems at a very, very fundamental level. And it can show you exactly where bottlenecks are in your code, right from the operating system calls all the way into your applications, right? So using tools like these, you're able to drive much better insights of your own applications, right? That will help you understand your own applications a lot better, which will help you optimize those applications as well, right? Which will help you prioritize what's a more important thing to fix or what's a more important thing to optimize and make more efficient, right? So again, observability is a lot more than just dashboards, right? And when you think about observability, think about both infrastructure and applications, and not just as separate entities, but correlated. Right? How does my application performance impact or how does my infrastructure performance impact my application performance, right? If there is a latency in the system, is that something related to my code, or is it something related to the infrastructure? We need to have this level of observability data being collected and insights generated to understand this, right? And again, collecting all this data and storing all this data is really no good unless it becomes actionable, right? That's where we have to really start integrating to our workflow, right? So, a workflow where, you get, PagerDuty, integration with PagerDuty or integration with Slack, where you can get these notifications as these events are happening, not later when the customer starts complaining about something, right? So that's where the real benefit lies, right? And there are tons of tooling, like I've put here, right? Sysdig, Thanos, some of them proprietary, some of them open source. And it's Kubernetes being the standard ecosystem, you can pretty much bring whatever tool you want into this ecosystem and still take advantage without actually having to go and re-platform and having to take hard dependencies on these tools for your application, right? You can swap them out in any order as you wish. Okay, let's try to move our focus to security and identity for a minute. So again, I kind of go back to the initial microservice architecture that I showed earlier, right? Compared to a monolith, we have much more services here. The dependency graph is larger. Every single service now depends on a bunch of other services. And every single service is exposing APIs and is becoming accessible independently. All of these are adding to the attack vectors, right? If you were to take a very cynical look at this, you can now go and point out every single API endpoint that you exposed can be attacked. Every single application that you split out can be attacked. Every single tool chain or every single technology stack that you used could bring its own vulnerabilities. You have a much wider field to cover now, right? If you were standardized on one programming language and one technology stack, that's where all your focus was, right? You pretty much didn't care about like any kind of vulnerability getting reported in some other types of technology stack that you didn't care about, right? Now, becoming polyglot, it becomes much more difficult and much more challenging to keep track of everything that's going on. Again, new threats emerge constantly, right? The CVE database gets updated, sometimes I feel like multiple times a day. And there is generally no single management plane, right? Because again, we come back to that, polyglot architecture, multiple moving pieces. Where is this one management plane that I can use to control everything, right? So we'll take a step-by-step look at this. So the first order of business would be to securing your applications, right? So within a Kubernetes ecosystem, again, the main points to focus on when you're running in production are how do you set up your access policies? How do you set up or how do you evaluate your security posture? There are tools available that can tell you everything from container supply chain to your actual infrastructure security posture. And these are the tools that you need to uptake, or these are the tools that you can leverage in order to get insight on like how secure am I, right? You can detect and address these violations. You can implement code scanning. Like a couple of good examples here are like, Aquasec or other third-party tooling that can provide this kind of features. Or if you're using OCI, then OCI's container registry has built-in vulnerability scanning. So every time a new CVE is reported into the CVE database, or every time you build a brand new image, the vulnerability check automatically happens and it sends you a report. You can have your Kubernetes clusters set up so that you only accept signed images into the cluster. is an image that you sign with your own encryption key, and only those images, because that's going to prevent man-in-the-middle attacks where, somebody published an image somewhere, but how are you sure that the image was not tampered with when you deploy it? So you can have your Kubernetes clusters verify signatures before it deploys any container. You can also implement perimeter controls, right? Like adding a web application firewall, which is at the outermost layer, right? It can prevent against SQL injection attacks or other common forms of attack vectors. Again, the focus is, regardless of the technology choices, regardless of the tooling choices, right? The Kubernetes ecosystem offers a lot of tooling, especially in terms of container supply chain, especially in terms of vulnerability scanning. And you can leverage these tools to make sure that what you're deploying in production does not have vulnerabilities. So we already talked a little bit about the container supply chain, right? This is essentially making sure that the code you deploy into your clusters, from the point that it's being built or the point that it's being checked out from a Git repository to the point that it is running live as a container in a cluster, it is secure all the way throughout. There are multiple tools that enable this. Also, you can enable continuous scanning, which will verify your or scan your actual runtimes continuously and report problems. The Oracle Cloud Guard, which comes as part of OCI, is a really good example of this, right? It can break it down. It can break down your security posture by compartment, by resource type, and give you alerts. Or it can even help you create recipes that can help automatically fix some of these. Like for instance, if you have a list of ports that is open on your network, and some other port gets opened by somebody, right? CloudGuard can immediately go in and close that port down. So the tooling exists, but we need to leverage it, right? And the same goes for governance, right? Because at a much higher level, we need to have some way of saying what kind of actions are permissible inside a cluster and what kind of actions are not. The most common example of this is like if you imagine the old three-tier architecture, right? There's this pattern where we say, oh, the UI layer shouldn't be talking to the database, right? The UI layer should be talking to the middle tier should be talking to the database, the UI shouldn't be talking to the database directly. Take that same notion and apply it to a distributed architecture. There are some services that need to talk to other services, and there are some services that have no business talking to other services, right? So in the architecture that I showed earlier, let's say fulfillment, the only service that might be talking to fulfillment is orders, right? Why would the UI talk to fulfillment, or why would the user management service talk to fulfillment service? There's probably no need, right? So policy-based control, where you say, I have a certain set of pods or a certain set of services, and these can talk to this other set of services, but anything outside of this is disallowed. And this is not just in terms of Kubernetes and pods, but this is in terms of overall security architecture. Who can modify what kind of resources as an operator, right? As a cloud user, who has the ability to create load balancers? Who has the ability to open ports in my network? Who has the ability to create compute instances, or who has the ability to terminate compute instances, right? It should be policy-based, which gives you an easy way to manage the complexity of the distributed nature of these applications, right? And this is where a service, and talking purely in a Kubernetes context, this is where a service mesh would really become relevant. Because for better or for worse, when we are modernizing an application, in a lot of cases we are not able to completely rebuild everything from scratch. we will probably have to reuse some parts of our application and move it forward, right? So a service like a service mesh, they essentially work. I mean, most of the service meshes today are proxy based. So that means they kind of wrap your service with a proxy layer, and the proxy keeps track of everything, right? Who's able to communicate with it, who's not able to communicate with it, how much can they communicate, gathers observability, all of that, right? So it's a transparent way of adding all these features to existing applications without necessarily changing the code, right? And it also helps you understand your application a lot better. You might start discovering patterns about your application, right? You might suddenly discover that, out of like 1,000 items added onto a cart, only 100 are ever checked out. You can start identifying patterns, and which will even drive business insights and application evolution. They can transparently communicate. They can transparently secure communications between all these services, right? Again, I'm harking back to the initial architecture slide I showed, right? Every service is talking to every other service. Who's stopping man-in-the-middle attacks there? Who's encrypting that traffic? And if you don't have the ability to add encryption, add these features to your application, a service mesh can transparently do this for you. You can even implement new features like rate limiting, right? Like if you have a service which maybe it's an expensive service and you want to say that, okay, only specific users can call this service as much as they want. Other users, I'm going to rate limit them. So you can implement these types of features as well with a service mesh. Which brings me to automation. Now, like we already saw, we have moved away from these monolithic applications, which, when you really think about it, were really simple to operate, right? Because you had like this one big application that you had to deploy, right? I mean, everybody had to like wait a couple of weeks so that everybody's check-ins are all merged, and we go through integration testing and all that fun before we actually make a release. So a release might happen, in best case scenario, once in 2 weeks, probably once in a few months, right? We move away from that to move faster. Every service can deploy whenever they want. They don't have dependencies. These are stable APIs they are depending on each other for. So when we are in this type of an environment, you have suddenly moved from one application deployment to probably 50. And how are you going to do that effectively without automation? So the only way to do that effectively is with a whole lot of automation, because we have more services that we deal with. We have more deployments, more build pipelines. We are dealing with variable infrastructure, dynamic environments, but we still want predictability and repeatability. Every time I deploy my application, I want that deployment to be predictable. I want my environments, my code, or the configuration to be fully repeatable, right? If somebody says, I want to create the exact same configuration as I have my integration test environment in production tomorrow, I should have a way of doing that, right? So a lot of this automation also comes back into converting a lot of what we used to do manually into code, right? So, infrastructure as code is a very common term, right, where we are describing infrastructure as code. Again, the benefit being, if it's as code, then you don't have to remember what you did. It's the code that's doing it. The same goes for applications, right? Like a Kubernetes manifest is essentially the description of an application as code. It specifically describes how is my application composed. What are the pods in it? What are the container images from which the pods are created from? What are the ports exposed? What are the services exposed? How do I target specific things? How do I pin certain pods to certain nodes? All of this information is encapsulated in that in that manifest, right? This also helps us do things like drift detection. Since it is all based on code, we are now able to go back and say, how has production deviated from the intended state, right? The most simple example of this is a firewall, where only port 80 and 443 were enabled on the firewall, right? One fine morning, you run a check and you see that port 8080 is enabled on the firewall. Well, that's drift. Somebody did it. We could probably look at audit logs to figure out who did it. But the ability to find that, okay, we have drifted from our intended configuration into something else will help us fix those, right? Again, the cloud native ecosystem offers multiple tools in this space, right? The most popular ones are Terraform, Ansible, and Crossplane, right? OCI has Terraform and Ansible providers that are publicly available today, and they both help you write infrastructure or create infrastructure as code, which makes your infrastructure deployments much more predictable, much more dependable, and you can have these abilities like drift detection, right? Kubernetes by its very nature is built that way, right? Nobody is deploying anything by hand, right? I mean, there is a specific description for what an application should look like, and it is expressed in a very specific as a Kubernetes object. So by its very nature, Kubernetes does this all the time, right? So again, the notion here is when we move on to automation, whether it's applications or infrastructure, we should try to leverage these tools to make the process more efficient, more predictable, and more secure. When it comes to applications specifically, though, we have a new breed of tools and a new class of deployment mechanisms, right? I mean, GitOps is a pretty popular way to achieve this. The central notion here being your Git repository is your source of truth, and everything happens through your Git repository. You want to open a port on your firewall, update your infrastructure code, commit it to your Git repository. That commit should trigger a deployment, and that's how the port gets opened. You never go to the console and use, like start punching in numbers, right? You don't do these manual actions. And if you do manual actions, that should show up on your audit report as drift, right? And you should get a slap on the wrist. So GitOps really promotes this idea of not just managing infrastructure code, your application code as well, right? When you have a new build or when somebody checks in some new code into Git, a tool like Flux CD or Argo CD can detect that. When a new manifest is checked in, it can go detect that and it can deploy it into a cluster so that there is no additional step for your creating your integration environment, right? Your new change is already available there. It's just now a question of promoting that change to some other branch and then the whole process repeating on some other cluster. Software management on Kubernetes clusters, right? Most people will start out with Helm, right? It's commonly called a package manager for Kubernetes. It's a really good way to encapsulate more complex software packages in Kubernetes and to have that configuration encapsulated in a very Kubernetes native way so that it becomes easier to deploy these, right? Most of the popular Kubernetes tools that are available today, like Grafana or Prometheus or even like Argo CD, which is also a tool, right? They publish Helm packages for it or Helm charts for it, right? It makes the process of installing something onto your Kubernetes cluster very trivial. But the operator framework takes it to the next level, right? It starts defining a full SDLC lifecycle for this, like not just how you deploy something, but how do you upgrade it, how do you downgrade it, how do you add features to it, right? And the operator framework specifically, there are multiple OCI services for which we provide operators for. The Oracle database is one, which gives you the ability right from within your application code or within your application's Git repository to define an Oracle database. Apply that manifest onto your Kubernetes cluster, and your Kubernetes cluster will create that Oracle database for you, and it will wire that Oracle database with your application, right? You can do the same thing with MySQL, the OCI MySQL service, right? Or for object storage or streaming. So operator framework not just helps install stuff, but also manages the full life cycle for it, right? Like for instance, upgrading your database. And this finally takes us into optimization, right? So one of the things that microservices do is that we move away from this notion of dealing with these large black box systems, right? They are fully decomposed into individual services. So there is full transparency on what's actually happening inside. So this gives us the ability to start understanding application patterns, right? To understand resource utilization. And application patterns are things like what I mentioned earlier, right? What service is talking to what other services more frequently? How do I optimize that? How do I scale just those services, right? If I'm giving all services equal resources, but I notice that order management service is always, at 100% CPU utilization, and it's always starving and struggling, right? Whereas some other service like user management maybe hardly, sees 2%, 3% utilization, right? So the natural thing for me to do at that point, once I've understood that pattern, is to go and optimize for it. I should start moving some capacity from the user management service to the order management service, right? That way, I'm not, bloating my infrastructure footprint, but I'm allocating the resources correctly where it's needed. And to identify where it's needed, we need the tooling and the insights that we derive from this tooling to properly identify what are the aspects where we need to focus on, right? And constantly, as applications evolve, as usage evolves, this keeps on changing, right? So Kubernetes itself has mechanisms to cope with it, right? Kubernetes has autoscalers for pods, which can automatically create and reduce, create more, or scale up or scale down the number of pods based on actual needs. We also have the cluster autoscaler, which can dynamically add infrastructure, right? So if the cluster has 10 nodes and 10 nodes are not enough, the cluster autoscaler can go and add more nodes so that we can satisfy the need. And when that need has dissipated, we can scale down as well, right? Because we don't have to, pay for resources that we are not using, right? So we need to scale, scaling down is equally important as scaling up. So now we are in the cycle of understanding application patterns, understanding infrastructure patterns, understanding resource utilization, using that understanding to optimize our infrastructure footprint and our applications, and we keep repeating this to the point that it becomes, almost part of the workflow. This is the workflow. Thank you.